Welcome back. In this video we will implement the first relationship of the example case. We are having a go at the one-to-one relationship. Have a look at the ER diagram again, and we can find a one-to-one relationship here between the book and the price offer. Notice that the price offer is optional. A book may have a price offer, while a price offer must have a book. Whenever you do one-to-one relationships, at least one side has to be optional. We call this side the dependent entity or child entity. That makes the price offer the child and the book the parent in this relationship. Sometimes both sides are optional and you must decide which is the child and which is the parent. The resulting mapping in a relational database is based on which is child and which is parent. You cannot have both sides being mandatory, as that would lead to a chicken and egg kind of situation. The way a one-to-one relationship is done in the database is to have a foreign key from the child, here the price offer, to the parent, which is the book. The mapping in the database actually looks like a one-to-many, so to enforce a one-to-one, we must add a unique constraint to the book ID foreign key in the price offer table. I symbolize this with a fingerprint because that's unique. Now we have a few ways of setting this up. First, we can add a navigation property from the price offer to the book. That's almost enough. We will get the foreign key in the price offer table. You can use this as is, but the database will not restrict you to only one price offer per book. You can then add a foreign key constraint through the Fluent API if you want to, but I will leave that up to you how to Google that. For convenience, I would also recommend adding a navigation property the other way, from book to price offer. However, now EFC will not be able to tell which table to put the foreign key in. We can help EFC by explicitly defining the foreign key in the price offer class like this. Following this naming convention, EFC will recognize this property to be the foreign key, and because we are now explicitly stating it is a one-to-one relationship through the two navigation properties, EFC will add the necessary unique constraint on the foreign key for us. Let's try this out in Writer. I'll just keep the relevant part of the diagram over here so we can see it. I already have the book entity from previous, and then we implement the price offer. It gets its ID along with other properties. Good. Now let me just open the book and price offer side by side. I'm going to put a navigation property in both entities. First, the price offer gets a navigation property to the book, and then the other way. As mentioned, I now need to explicitly add the foreign key. We put the foreign key into the child, which is the standard approach. Alternatively, I could actually define a foreign key through the Fluent API, which is called a shadow property. But again, I leave this to you to Google how to do that. So in the price offer, I will add a property of type int and name it book ID per the naming convention. Let's just see what EFC would generate based on the current setup. So I open the terminal and make sure the location is correct. Then type in this command you have seen before, which will just generate the SQL script necessary to create a database based on my current configuration. Here we can see two tables, and the price offer table has a book ID attribute, which references the ID of the book table. We can also see the unique constraint on the foreign key. I am satisfied with this output, so we should now actually update the database. First, I want to add a DB set for price offer to the DB context. As you saw in the output script, this is not strictly necessary. EFC knows about the book from the DB set of books, and EFC will detect associated classes and create the necessary tables, in which case we get the price offer. And we just saw that EFC correctly identified the price offer class. However, defining the DB set price offer is just more explicit and more convenient. And next, back to the terminal. Generate a migration, which we get here. Then back to the terminal and update the database. And now let's just inspect the result in the database view over here. I have the attributes, I have the primary key, and there's the foreign key, And I have the unique constraint, which is the index here. There are no surprises here. I get the price of a table with the correct structure just as I expect it to be. And that should be it for your one-to-one relationships. In the next video, we will deal with one-to-many relationships. So see you then.